Trying to steal the computer screen. And here we are. So antivirals, a lot of fat stuff here, so we're just going to run through it pretty quickly. What is a virus? It is a small, infective particle. But very specifically, is it an organism? This has, of course, been a subject of large controversy. The general consensus is that no, it is not an organism. Now, how do they differ from bacteria, which we talked about when we did antibacterials? The truth is that they are not organisms. I suppose that's one way, but they're also not cells. Well, I suppose that probably follows. They're not cells. They're much smaller than bacteria, which makes them a lot harder to filter out with air filters and these kinds of things, because they are much smaller than bacteria. Also, they don't have all the organelles that other bacteria or other living things have. What is located inside a virus is DNA or RNA or both. Certain viruses have different nucleic acid material, genetic material, and so that is going to be a key part of how they work. In what structure is this located? This is located in something called the capsid. And in case you're not familiar with what the capsid was, you probably have heard of it before, but here's like your classic alien-looking virus. The capsid is this protein-rich area up here. It is a protein-rich structure in which all the genetic material is stored. These kind of tentacles or legs over here are going to become important in a little while. But anyway, that's what a particular virus looks like. There are lots of different shapes for different viruses. Look, viruses have no nucleus. They have no cytoplasm. Are they cells? I mean, I already said it, but no, they're not cells. They also don't feed, they don't respire, they don't excrete, and they don't grow. They need a host in order to survive. Well, that's probably actually one way that they differ from bacteria. Need a host to survive and replicate. This is a key difference and one of the reasons why they are not considered living, is they can't replicate on their own. Now, viruses obviously must be able to, survive outside of a host for a little while. Otherwise, we wouldn't be able to transmit them. Whether it's cold viruses going through the air or stomach viruses going through, on surfaces and things like that. Obviously, they must be able to survive outside a host for some time, but you should be able to at least write that it's only for a limited amount of time. It does depend on the individual virus. So certain viruses are more sturdy than others. Cold viruses generally are good for a couple of hours on surfaces. Some stomach viruses can be up to a day or even more, depending on the conditions. But for the most part, very limited amounts of time. Other viruses like HIV can survive on surfaces usually for more than about 30 minutes. And even that, is on the high end. So what happens when a virus invades a cell? This is the nasty, nasty part. Okay, Kyle is apparently resetting the carbon monoxide detector. Oh my, I hope we're okay. No, that's just the test sequence. We're fine. Okay, what happens when a virus invades a cell? And I promised you I wouldn't scare you while I was there in class, and we'd do it at home when you were going to bed, but and really create nightmares, but apparently we're just going to do it in class. There are 5 things that happen in succession when a virus invades a cell. First thing it does is that it attaches, oops, I didn't want to do that. No, forget it, we'll just do it this way. Attach to host cell and inject DNA, or I guess RNA, depending on whatever it has, okay? That's the first thing it does. Already it doesn't sound good. That's through those tentacles, those legs that you saw. Then come on. The virus takes over cell processes. It then forces viral replication inside the cell. Next, it kills the cell at this point. And once it kills the cell bursts, which releases all of those replicated viruses, which then, of course, go ahead and do the same thing other places. Lovely, right? So this obviously changes the game regarding treatment, because unlike bacteria, where you can treat it with an antibiotic, virus isn't a living thing, doesn't have a cell wall. You're not going to use antibiotics. It's not going to do the same, not going to require the same kind of treatment. And in addition, the whole mode of action is different. And this is pretty insidious stuff. So let's talk about treatment. Let's try and figure out how it is we've gone about taking care of this. What are some examples of common viral infections? I mean, I've kind of mentioned them already. Typically, I do this in class, but whatever. It's common cold, influenza, so the flu, which is different than stomach viruses. Okay, stomach viruses are not, there's no such thing as stomach flu. Okay, stomach viruses there are different viruses, rotaviruses, noroviruses. Common cold are called rhinoviruses. Get it? Rhino, like nose virus. What's the usual treatment for a virus? What do you take for a cold? You take that ridiculously ineffective Robitussin, or you take Mucinex, or whatever it is you want to take. But what are you treating? You're only treating symptoms. You're not actually trying to attack the virus. Usual treatment is just symptom control. What ends up happening eventually is that the virus can't keep it up, and eventually your body's immune system comes and takes it over and swallows up the viruses, and everything's fine. That takes a few days, but really your usual treatment is only symptom control. Viral infections are difficult to treat. One reason is that they replicate awfully fast. So you got to think about it. So let's write that in, replicate very quickly. So the thing is that initially when you get infected with the virus, you don't have symptoms, and by the time you have symptoms, guess what? It's too late. Oh, I guess so. So when symptoms have appeared, it's too late to kill the virus. You might as well just treat symptoms, because by the time you treat the virus, essentially it's going to be taking care of itself anyway. However, there have been a few drugs out there that have been developed recently to combat viruses. And there are two main ways that these drugs operate. And then we're actually going to talk about some of the newer drugs that have come out to treat flu. That's the end of this topic. That's the added piece. All right, so one is to alter the cell's genetic material so that the virus can't use it for multiplication. So there are two similar drugs, acyclovir and ganciclovir, which I'll have pictures of in just a second. The drug acyclovir mimics deoxyguanosine. So here's a picture of acyclovir. Oh, I had it. I have amantadine, but I had acyclovir. I don't know what I did with it. Is it over here? Nope. All right, I'll just go get it again. Acyclovir Wikipedia. All right. You know what? This is hanging up, so I'm going to press stop.